Today we're going to review the different translations that we've been looking at. We're going to start with the square root function. It says, for the warm-up, sketch and label the following functions. Y equals the square root of x. So we looked at this yesterday in class, but if you forget what a function looks like, you can graph it in your calculator. So let's do that. Alright, so I'm going to type in the square root of x, and we can see what the function looks like right here. So if we sketch that function, let's do it in blue like it was on the calculator here. The square root of 0 is 0, the square root of 1 is 1, the square root of 4 is 2, and we can sketch what this function looks like. Okay, so here is the square root of x. Let's graph y equals the square root of negative x. Again, if you forget what the rule is, you can type it in. On the calculator, I'll hit tab. I'll do negative square root of x. And we can see this is the function that's flipped over the x-axis. So let's graph that. So this is negative square root of x. And let's graph the last one, where it's the square root of negative x. Again, if you forget what it looks like, I'm going to hit tab and do the square root of negative x. And we can see that this one flips over the y-axis. So we'll graph that over here. So this is what we looked at yesterday, how you graph a function where the negative's in a different spot. So today we're going to review all the different functions we've been looking at this unit. So we have the name linear. If I write the parent function that we've been looking at, the equation of this function is y equals x. The y-intercept is 0, the slope is 1, so we have y equals x. If it's a quadratic, the parent function was y equals x squared as the highest power. The v-shaped graph was absolute value, so we have y equals the absolute value of x, and then the square root function we just looked at. So you should know the name of the function and what the equation of the parent function is. Let's review the general rule and how these functions shift. We know that for the square root functions, if it's underneath the square root sign, it's like there's parentheses there. And we've been looking at the pattern for parentheses. If it's in the parentheses, this is left and right. And it's the opposite of the sign. So the -3 means this function would move right 3 units. If I were to graph this, I would take this and move it right 3. 1, 2, 3. And then you would sketch your function. Okay, the next one, if I go back, the absolute value of x plus 5 outside the parentheses, or the absolute value, is up or down. So plus 5 is up 5. This one's a combination of 2, so the plus 6 would be left 6, down 11, and that would be a square root function. If we have a square root function, or a squared function, a quadratic, it's a U-shaped graph. And again, inside the parentheses is left or right, and the minus would be right 3. The plus 15 would be up 15. So again, if it's inside the parentheses or the absolute value or the square root, it's left or right. The plus is left, the minus is right. And then on the outside of the parentheses or absolute value or square root sign, it's up or down. Plus is up, minus is down. So let's see if you can sketch these. Sketch the graphs of the following functions. So the first one, the shift, I'm going to write first. The plus 3 means left 3. The plus 2 on the outside means up 2. So I'm going to go left 3, 1, 2, 3, up 2. And it's a square root function, so we know it looks something like this. The next one we have on the inside -3, so this means right 3. The plus 5 is up 5. And the -2 means the slope, I'll call it, is -2. So right 3, 1, 2, 3, up 5, 1, 2, 3, 4, 5. Do this in a different color here. So here's the vertex where it changes direction. The slope is -2, means we go down 2 over 1 in each direction. And then we can sketch our line. It's a V-shaped graph. It'll be upside down and skinnier because of the slope is -2. Okay, let's take a look at the next two. Okay, so again, the shift, the +4 in parentheses means left 4. +3 means up 3. And the minus means it's upside down. So this is a quadratic, so it's going to be upside down. So left 4, up 3, and it's an upside down parabola. Okay, the next one is right 1, down 3. I'm going to give myself more room here. So right 1 is the -1 here. The -3 means down 3. And then we're going to say our slope is 1/2. So right 1, down 3, 1, 2, 3. There's the vertex. Slope is 1/2. It means you go up 1/2, up 1/2. And you can see that this one's going to be wider than the original function. Okay, so there's drawing the functions. And now the last thing is we're going to, well, second to last thing, write the equation of the shifted function. All right, so this is the square root function. Let me give myself more room here. Oh, good to me. And this one goes left 2, and then this is being scaled by 1, so up 1. So we have y equals the square root. Left and right on the inside. Left is plus. And then up 1 on the outside, so +1. Okay, the next one, absolute value. This goes right 3, down 4. Let's check the slope. Here's a 1, so it looks like we go up 1, over 1, up 1, no, up 1, and we go over 1/2. So up 2 over 1, yeah, so up 2 over 1, up 2 over 1. So here our slope is 2. So if we write this equation, we have y equals, we'll put the 2 on the outside, it's absolute value. It's right 3, so x minus 3, and then down 4 minus 4. Okay, we got 2 left. 2 parabolas, so we know the parent function is x squared. And again, let's see how it shifts. So this one goes left 4, goes up 3, and it's upside down. So we have y equals, the upside down is negative, and then left 4 is x plus 4. It's a parabola, so you need to square it on the outside, and then up 3, so +3. And our last parabola here, switch colors. This one doesn't go left or right any, but it does go up 1. And it's a smiley face, so it's positive. So y equals, and if it's up 1, x squared, nothing in the parentheses, plus 1. So you can put the x in parentheses, you don't need to. So I could just erase them. I'll just leave it x squared plus 1. Okay, last type of question. Is it narrower, skinnier, or wider, or fatter than the parent function? So let's take a look at these. And this all deals with that number in front. Remember, if it's negative, it's upside down. But if it's positive, it's right side up. And the rule is if this number is, so I'll call this the A value, if the absolute value of that, so positive or negative, if that is less than 1, it's going to be fatter. And if the absolute value of A is greater than 1, it's going to be skinnier, steeper slope. Okay, so this number is less than 1, so this is going to be wider. You would go, this is 0.75, so 3/4, up 3 over 4. This one right here, 7, is going to be skinnier than the original, much steeper slope. The 0.5 is less than 1, it's going to be wider. And the -4 is going to be skinnier. It will also be upside down. So if you wanted to test these, you could graph them. So let me just clear this. Okay, so let's just graph the parent function and then the second function. So the first one was x squared. And then if I wanted to test 0.75 and see that it's fatter, you could do 0.75 x squared. And you can see that it is wider. Let's try the next one. Show you that it's skinnier, so it's 7x squared. So again, I'll do the parent function x squared. And then 7x squared. You see it's a lot skinnier. And you can do the same with absolute value. So I'll graph all the absolute value on one. Okay, so absolute value, remember, is next to the book button, or next to the number 9, there's absolute value of x. So here's the parent function. And then I'm going to graph the next one, 0.5 x plus 1. So we can see that it's a lot wider and it shifted up one. Let's do the last one, which was -4. So it should be skinnier and upside down. So you see it's a lot skinnier than the blue function and upside down. So you can use your graphing calculator if you forget any of these rules. Okay, so today you're going to work on the review in class.